Hey Algebra 1, and thanks for tuning in. Today we're going to be looking at lesson 9.1, which is part 2, Rationalizing the Denominator. Today we're going to be looking for 9 things to go on our notes. Let's go ahead and get started. First thing we want to know is what does it mean to rationalize the denominator? And that happens when there's a radical in the denominator of a fraction. Okay? We want to do this because we don't ever want to have to leave a radical in the denominator. How we can do that is we can multiply the fraction to eliminate the radical from the denominator. You're essentially just going to multiply everything by the denominator, because that's where the radical is going to be today. And so let's go ahead and we're going to try some examples with that. Let's go ahead and pause here just so you know, so you can write down what it means to rationalize the denominator, and then click play so you can see how it's done. So here's an example of what we have. We have the square root of 5 over the square root of 3n. And so what we're going to do first is just multiply both top and bottom, the numerator and denominator, by the square root of 3n to try to get rid of that radical at the bottom. When that happens, we're going to get the square root of 15n, because 5 times 3n, and then the square root of 9n squared. 3 times 3 is 9, and n times n is n squared. Remember, that was the product property of square roots that we talked about in the previous video. Once we have that, then we can break down anything that can be found as a square root. So 15n is going to stay the same, but we can find the square root of 9, which is 3, and the square root of n squared, which is n. So that's essentially what we're going to do here. This is a great example to write down in your notes. That's why I highlighted it and put that number 2 up there. So this is going to be number 2 in our notes. Let's go ahead and pause the video now so you can write down how it's done, so you have a good clear-cut example showing the work. Once you're done writing this down, go ahead and hit play so you can try a few examples on your own. So here are some examples for 3 through 6. Let's go ahead and get you to pause here. We're going to try to rationalize the denominator, meaning multiplying both the numerator and denominator by the radical in the denominator. Alright, so we've gotten a chance to try the 4, so let's go ahead and see how they're done. So for number 3, I started off by multiplying both top and bottom by the square root of 5. So I'm going to get the square root of 5 on the top times the square root of 25, which essentially will lead to the square root of 5 over 5. Make that look more like a 5. Sorry for sloppy handwriting. Alright, number 4, we're going to do the same thing. Square root of 3 times the square root of 3. So we're going to get the square root of 30 on the top, and then the square root of 9. Then when we break that down, we're going to have the square root of 30 over this, or over 3. The square root of 30 can't be broken down into a perfect square, so we're going to leave it just like that. Number 5, you should have multiplied both top and bottom by the square root of 2x. So if we multiply the top number by 2x, the square root of 2x, we get 7 times the square root of 2x. And then on the bottom, when we do 2x times 2x, we get the square root of 4x squared. Then we're just going to simplify as much as we can, so we get 7 times the square root of 2x over 2x. Noticing that when you're multiplying the radicals together, like the square root of 5 times 5 is just 5. The square root of 3 times the square root of 3 is just 3. So maybe that's an extra step that you could take out of your work. The last one in number 6, I would recommend maybe breaking this up into that quotient property we talked about in the previous video. So we have this if I break it up, and then we multiply both top and bottom by the square root of 3. So on the top I would get 6y squared in the square root, and then over 3. I do see one thing I can break down. The square root of 6 and the square root of y squared. The square root of y squared has a perfect square, so I'm going to go and find that. So my answer would be, you can say the square root of 6 times y over 3, or it might just be better to say y times the square root of 6 over 3, because you don't want it to look like the y is still a part of the radical. Okay? We're going to now talk about something called conjugates, and this is just meaning when a, b, c, and d are rational numbers, they're called conjugates. So a times the square root of b plus c times the square root of d is equal to the differences of those two multiplication and radicals. You can use conjugates to simplify radical expressions, and that's exactly what we're trying to do here, that contain a sum or difference involving the square roots in the denominator. This might seem like a lot of stuff. Let's go and just write it down first, and I'm going to show you an example to show you how it's done. And then once you're done watching that example, you're going to try 2 on your own. All right, so here's an example. We have 7 over 2 minus the square root of 3. What I'm going to do here, in order to simplify it, is I'm going to multiply it by its conjugate. So what that looks like is this. Instead of saying 2 minus the square root of 3, I'm going to do 2 plus the square root of 3. But whatever I do to the bottom, I'm also going to do to the top. Okay? What's going to happen here is I'm going to get 2 times 2, and then the square root of 3 times the square root of 3. So that would give me, on the bottom, 2 squared minus the square root of 3 squared. Okay? On the top, I would get 7 times 2. It's almost like you're distributing the 7 plus 7 times the square root of 3. Now we're just going to simplify that. 7 times 2 is 14. 7 times the square root of 3 is just 7 times the square root of 3. And then on the bottom, I'm going to get 4 minus 3, because the square root of 3 squared, that's going to give you 9. Square root of 9, square root of 9 is 3. Here's my work to show that. Okay, and then I'll just keep simplifying until I can't anymore. I can do something here on this bottom. That's going to change that to 1. So initially I might write this, 14 plus 7 times the square root of 3 over 1. But really I need to make sure that I simplify completely. So I'm going to move to the left here. So I'm going to have 14 plus 7 times the square root of 3 as my answer. Okay? So what we're going to try now is 2 examples simplifying using a conjugate. So here they are. Let's go ahead and try these 3. Sorry, we do have 10 questions. And then see how we do after we're done. So let's go ahead and pause here. Try 8, 9, and 10, and then click play when you're ready to check. Alright, so for number 8, I multiplied both the top and the bottom by 1 minus the square root of 3. Okay, that would give me on the top 8 minus 8 times the square root of 3 over 1 times 1 is 1 squared minus the square root of 3 squared. Okay, that's going to give me on the top 8 minus 8 square root of 3, and on the bottom it would give me 1 minus 3. Okay, to simplify this even further, I notice I'm going to get negative 2 on the bottom, so 8 minus 8 square root of 3 over negative 2, and then I'm going to just find a number that I can simplify that with. And really, I can take this negative 2 and simplify it with the positive 8 and the negative 8, because it's almost like they're individual fractions. So my answer for number 8 would be negative 4 plus 8 square root of 3. Okay. For number 9, what I did first in number 9 is I rewrote it so that the constant would be shown first. So this is what I did. And then I went ahead and did my conjugate. So I'm going to multiply both sides by negative 2 minus the square root of 5. And then go and start simplifying. So I'm going to get on the top, negative 2 times the square root of 13, and then minus the square root of 65, because 13 times 5 is 65. And then on the bottom, negative 2 times negative 2 is 4, and then minus the square root of 5 squared. Okay, that's going to give me, still on the top, negative 2 times the square root of 13 minus the square root of 65 over 4 minus 5, which would give me negative 2 square root of 13 minus the square root of 65 over negative 1, which is essentially just going to change everything now to its opposite. So I'm going to scoot down just a little bit. So I'm going to have a positive 2 times the square root of 13 plus the square root of 65. Okay, that one was a little bit more complex than the previous one. That's okay. The last one we're going to look at over here, number 10, is, we're going to show that conjugate again. So we're going to times everything by the square root of 2 minus the square root of 7. Let's scoot up here. Alright, so on the top when we multiply, we're going to get 12 square root of 2 minus 12 square root of 7 over basically 2 minus 7. 2 times 2, 7 times 7, find the square root. That's going to give us 12 square root of 2, bring that down, I'm going to run out of room. 12 square root of 2 minus 12 square root of 7 over negative 5. You can keep it like this because you can't simplify anymore, or you can just bring this negative out front, so the negative 12 square root of 2 minus 12 square root of 7 over 5. Both of these would be appropriate as your answer. So 10 was actually pretty easy. So that's going to conclude our notes for today. Thanks so much for tuning in, and we'll catch you next time.